Welcome to a new ADI video series highlighting one of our up-and-coming prototyping platforms, the SWIOT1L-SL. In this presentation, I'll cover box contents and then go over hardware details, features, and capabilities. The module offers ultimate flexibility in the configuration of 4 input-output channels, processing at the edge, and built-in security. This makes it an ideal starting point for prototyping intelligent, secure, and network-capable devices with applications such as factory automation and process control. Inside the box, you will find the AD-SWIOT1L-SL board in an enclosure compatible with DIN rail mounts. The smaller board is a 10-base T1L to USB adapter board. This board will expose the system as an Ethernet interface on your computer. There are 2 cables inside, one Profibus cable for single-pair Ethernet connectivity and one USB 2.0 cable. Finally, you will see 2 connectors, one for the I/O channels and one for the external power supply. The configurable I/O channels are provided by 2 integrated circuits, AD74413R, a quad-channel software configurable input-output circuit, and MAX14906, a quad-channel software configurable digital input, digital output circuit. Connected to the channel's terminal block, these offer several analog and digital functions, current input-output, RTD measurements, and voltage input-output, either analog or digital levels. For analog voltages, the range is 0 to 11 volts, while digital levels can go up to 24 volts. The onboard microcontroller MAX32650 provides all the debugging and programming components to enable software development on the system. Equipped with 128 MB of external RAM and 8 MB of external flash, the system yields flexibility towards protocol stack while still meeting requirements for demanding applications. The security features are ensured by the cryptographic controller MAXQ1065. Network connectivity is enabled via a 10 megabits per second single-pair Ethernet link handled by the ADIN1110 10-base T1L MAC-PHY. This permits remote device configuration and data acquisition. The 10-base T1L interface can also be used for powering the system via the single-pair Power over Ethernet technology using the LTC9111 Power Device Controller. This configuration reduces the complexity of cabling infrastructure. However, if high current is needed in certain applications, the system offers the option to be powered from an external 24-volt supply. This enables a current output of up to 1.2 amps per channel. The power supply solution includes the ADP1032 high-performance isolated micropower management unit to provide power and digital control for software configurable I/O devices in one of the most compact formats. The LT8304 micropower no-opto isolated flyback converter completes the power tree to provide isolated power to the digital part of the design. The power configuration is set by the power switch accessible on the board. The entire software stack is open source, thus enabling not only the evaluation of the system, but also application and firmware development. For evaluating the product, a user-friendly graphical interface can be installed on your PC. This provides an easy way to configure the system. Moreover, the acquired data can be displayed several ways. We'll take a closer look on how to use the application while further detailing the device's capabilities in the next video of the series. The system's firmware is based on Analog Devices' open-source NoOS framework, which includes all the tools required for embedded code development and debugging, as well as libraries enabling host-side connectivity for system configuration and data transfer over the UART or the 10-base T1L interfaces. For firmware programming, an external programmer is required. We recommend using MAX32625PICO MaxDAP programming adapter, but similar devices that support the SWD interface will do. The firmware makes use of the IIO framework. This makes it possible to develop custom applications based on ADI's open source library for interfacing IIO devices, libiio. The C library also provides bindings for C++, C#, and Python, enabling flexibility when it comes to choosing the programming language for your application. For Python applications, ADI also provides an abstraction module for interfacing the hardware. PyADI IIO simplifies the code development process, leading to faster results. We'll look into using the module in the third video of this series. This concludes the general presentation of the AD SWIO T1L-SL platform. In the next video, we'll talk about evaluating the system using ADI's GUI application Scopy. For additional resources and information, please check out the links to the documentation given in the description. If you've got any other questions, feel free to refer to ADI's support forum, Engineer Zone. Thanks for watching.